In today's class, we are going to discuss on linear regression. Where this linear regression comes is, it comes under machine learning and under the category supervised learning. So there are two types of learning, supervised and unsupervised, as well as reinforcement learning. There are three actually. It comes under supervised learning. That means we will use the labeled data for the training. Okay, so that's the thing. And we will discuss what is this linear regression and in what are the applications we will apply these linear regressions. From the definition, we can say linear regression is a machine learning method used to model the linear relationship between a dependent variable and one or more independent variable. First, we have to learn what is dependent variable and what is independent variable. So this is very important. The dependent variable is the variable that is used for learning. An independent variable or the variables that will predict, that is also called as output. Okay, I will explain with an example. There are two types of linear regression. One is simple linear regression and multiple linear regression. The simple linear regression is, it has single independent variable and one dependent variable. Dependent variable is always one and the independent variable is one. Okay, we will see from the example. For example, we are going to predict the price of the house based on the size. So here the size is the independent variable. The price of houses is dependent variable. That means the price of the houses depends on the size. If the size is high, then obviously the price of the houses will increase. If the size is low, the price will decrease. So that's why the size is called independent variable and price of houses is called dependent variable. The dependent variable or the one depends on the independent variable. In that example itself, we can say the price of the houses is not only depend on the size, it is also depend on number of rooms. We can take the number of rooms also. Okay, and then the first floor and the second floor is another variable. Number of rooms we can take, and the first floor and the second floor we can say, and the new home and the old home, that is also we can, the age of the construction also we can see. So there are different types of variables. Based on that only the price of the houses will be determined. We can also say that the location of the house, where the house is located, it is near to the city or far from the city. Based on that also the price of the houses will vary. All those parameters, the parameters that we discussed so far, the size and the number of rooms and the floor and the locations, whatever it is, all these are called independent variables, and the price of the houses here is dependent variable. So that is the concept behind independent and dependent variables. And why it is called linear means it should have a linear relationship between the independent and the dependent variable. For example, what is linear means? If the size is increased, the price will also increase. If the size is decreased, then the price of the house is also decreasing. So that's why it is called linear relationship. Linear relationship means when the dependent variable increases, independent variable will also increase. Okay, and vice versa. Now we move to the next point. This will be framed in the mathematical form as, this is called dependent variable, and this is called y-intercept. There's a constant, and this is the slope coefficient. It is also a constant, and this is the independent variable. We can frame this in a linear equation because there is a linear relationship between the independent variable and dependent variable. This linear regression will work fine only when there is a linear relationship between the independent variable and dependent variable. Okay. So here you can see what is this B naught. B naught is nothing but y-intercept. Y-intercept means this is the linear line. Okay. How this linear line is formed, I will tell you. Okay. So this is the linear line and this will be intercept with this y point. This y point is called B naught. And what is this B1 is? This is the slope coefficient. So how much the slope? This is the slope. The line may be like this or the line may be like this. So this is the slope coefficient. That is the B1 value. Okay. And X1 is the independent variable. Here you can say it is a size. And Y naught is the Y is the dependent variable. Dependent variable is the price of the houses. What is this data point is? This is the data point from the data set. And we will learn that when we are applying it. So for example, when the independent variable size is this much, the price will be this point. This is the price. Okay. Here, when the independent variable is this much value, okay, and the price, the price for that value is this here, then we can have a point like this, isn't it? So this is the point. So like that, the data point has been mapped in the two-dimensional graph. Based on this data points, this line is calculated. This is the optimal line, or we can say it is a predicted line. Okay. So this is the first point. First point is the first point in the data set for the particular value of the size and the particular value of the price. This is the data point. Similarly, for the second, for the third, for the fourth, for the fifth, like that, you have multiple values in the data set. Okay. Based on this data points, you will have one line. This line is called, and why this line is called predictor line. Okay. So this value is based on these points. Okay. So this is the optimal line. This line may be here also. Okay, this line may come here also. But when you calculate the difference between the actual data point and this line, you will have lots of error. Okay, when you have the line here, you have the minimum error. So that's why it is called mean square error, minimum value. Okay, we will find the mean square error. Okay, so that is nothing but y predictor. This is the y predictor line, and this is the actual y, that is equal to cost function. When the cost function is small, then the error is minimum. When the cost function is large, the error is maximum. So based on the mean square value, this is the mean square value, means the sum of all the errors, difference between the predicted one as well as the actual point. Okay, so this is the error. So we'll calculate the error. Based on that error, we will have this point. And the next thing is, again, I said that we have to find the minimum cost function. How we are going to find the minimum cost function is with the help of gradient descent. Here you can say this is the gradient descent. So why the gradient descent is used? To find the minimum value of the error. So the error may be here. So you can see now, here this is the point where the error is much. After that, we will find another point, another point, another point, another point, another point, another point. And finally, we will reach the minimum error. Where the minimum error is achieved, that is in this point. Okay. Okay. So this is the minimum error. And this is the maximum error. So when you slowly see this, you can able to identify. So this at this point, the error is maximum. You can see this number. This point, the error is 370 something, and then slowly it is coming down, coming down, coming down, and the error is reduced to 0.5 something like that. The error will not be reached to 0, around 0 point something like that. So how we are achieving that? With the help of gradient descent approach. Okay, so that's the method that is behind the linear regression. In the multiple regression also, the same thing. In the multiple regression, you will have different independent variables. You will not have only one independent variable, you will have different independent variable. Here you can see the price depends on the advertising as well as the price sales. So there is another variable. Here you will not have a single line, you will have a plane. Okay, you will have a plane. You can see the blue thing, that is called plane, and you have the data points. These data points are from the data sets. Okay, so this is the multiple linear regression. The only thing is there you will have only one independent variable. So that means x and y. X is the independent variable and y is the dependent variable from the data sets. Based on that, you will have one line. But here in the multiple, you will have the single independent variable. There you have the multiple independent variable and single dependent variable. So that's all about this linear regression. You can see here you have one b naught, that is y-intercept, and you have multiple independent variables. That means x1, x2 up to xn. So x1 may be size, x2 may be rooms, x3 may be location. Like that, you have multiple independent variables. I will explain this when we are implementing the data set. So until now, this is the quick introduction of linear regression. That we'll move on to the implementation. I will explain this from the data sets, how the data set is working. You can see this is our data set. Here you can see this is a medical insurance document. There you will have the age, sex, BMI, children's, smoker, region, and charges. Okay, I already told that machine learning needs a data set to learn. Without data set, the machine learning will not work. The three parameters are very important. One is data, another one is algorithm, third one is the computational power of the system. So these three things are very much needed for AI. So in the data set, this is the data set available from the insurance company. There they will have the parameters. So these are the independent variables. So age, sex, BMI, children, smoker, region. So these are the independent variables. And charges, how much charge for a particular customer. For if the customer age is 19, the charges is something 1684. Okay, so like that they will have something because he is a smoker. So when he is a smoker at the age 19, definitely you will have some diseases or like that. So the charge is high. When there is he is not a smoker and his body weight is also same as normal, and his age is 28, then the charges is being reducing. So like that, they will have some criteria, age, like that. So this is the data set available. These are the independent variables. I said no, these are the independent variables. And this is the dependent variable. Based on this value only, the charges will be changing. Okay. So this is the data available in the insurance company. What the insurance company wants is, they want a model. In that model, they want to create a model. In that model, if they give the age, if they give the male or female, and BMI, children, number of children, and is a smoker or not, and region, if they give the region into that model, the model has to give them the charges. Okay, they no need to go and ask the insurance company. They have to fill this value. This value itself enough for the model to generate the output. The output is the charges, the dependent variable. Okay, they want to create one model. So that is our aim. So for that, they have given the data set. This data set is very big. It is around 1339 entries. So based on this only, we are going to create the model. After creating the model, that model will help us to find out the charges based on these values, any values. Okay, test values. We can call that as test values. Now we will see the implementation of this. So this is all about the explanation of the data set. Okay. Now we move on to the next part. Go to Google and type Google Colab. Okay. In your browser. So first we need to import the libraries. This is the first step when you want to create a model, machine learning model. The first step is you want to create a library. You have to create the library. So how you are going to do that is, so just create the lesson. Okay, you create one code set. So the libraries, the common libraries that is needed for machine learning is pandas, numpy, and matplotlib. So these are the three things that is needed. So I've seen, you can see in the code, import numpy. Numpy is one of the library function, and pandas is another library function, and matplotlib is another library, and seaborn is another library. So all these are common. Okay, so is commonly needed for creating the model. So what is this numpy is doing? What is the use of this numpy library is to deal with the array, to deal with the array functions. So mostly your data set is in the Excel format, and we have to take the data in the form of array. Okay, so that's the first step. Another one is pandas. Pandas has to deal with the tables. There is rows and columns, and we have to address the rows and columns with the help of the library function called pandas. And matplotlib is mainly for to see the um, data in the graphical format. So like we have seen, no, the X and Y, like that. If you want to see the data in the graphical format, then you can use matplotlib. Seaborn is for statistics. If you want how much values of people smoking, how much people are not smoking, if you want the count, if you want the statistics of the data set, then we need a Seaborn. So these are the common library functions that is needed for the machine learning algorithms. Okay, so just copy this and paste it in the cell. Okay, so you can, if you want to, you can type, but the time is limited, so that's why I'm copying and pasting it, and just run it. So when you run it, it is taking some time, and you'll have one tick. So that tick is all the libraries has been imported on your notebook. Okay, all the libraries has been imported on the notebook that you have created. Okay, it's just easy. But if you take any other ID like PyCharm or Spider or Jupyter, you have to import the library uh, specifically one by one into the IDE, and then you have to work. But in the Google Colab, it is not the case. Already it is there in the server. By just clicking, you can able to import all the library functions into your notebook. You can use that library functions as easy. So that's why Google Colab is very useful for learning the machine learning algorithms. And the next step is importing the data set. So first step is importing the libraries, that is basic libraries needed for machine learning algorithm. The second step is importing the data sets. How we are going to import the data set? So this is the code for them. Okay. So just open the code cell and then paste it over. You can see this is the variable. You can give any variable here. Either you can give data set or instance underscore data set, no problem. It's your option. And PD, what is that PD? PD is the pandas. Pandas is used for dealing with the tables. Okay, so your Excel file is nothing but .csv file. .csv file means comma separated value file. Okay, the name of the file is, so we have uploaded here. So we have not uploaded in this copy file. I'm just uploading here. Okay, so that is insurance So before that, you have to upload. Okay. So this is .csv file. You have to give the same name of your, the name should be same. The data set name here is insurance. Here also it is insurance.csv. So that is the only thing you have to see, and you have to upload that file here. And this is the function pd.read_csv means pandas.read_csv that will read the data in this insurance, and it is stored in the insurance underscore data set. So if you run this one, you will have the tick mark. That means all the insurance.csv file is readed and it is stored in the variable insurance underscore data set. So what are the things that is in the data set? I already explained. Age, sex, BMI, children, smoker, region. In this, you can see the sex here is female and male. So it is a letter, it is a character. But age, it is 1918, it's a number. BMI is also number. Children is also number format. Smoker is in yes or no. And region is southward. This is also a character. And charges, this is the dependent variable. It is also a number. The algorithm, any algorithm, if you take, it will not learn the characters. It will learn only the numbers. It will process only the numbers. It is because it is a mathematical. While explaining the linear regression, I have explained, and it is based on the equation, mathematical equations. So that means it will read only the numbers. It will not able to understand what is this yes or no, southwest, female or male. It cannot understand. So we need to convert this into number. Okay. So whenever you have the characters in the data set, then you have to convert that into number with the thing called encoding. So that is called encoding process. Okay, so this is the categories: sex, smoker, and region, or in the character format. We need to convert that into numbers. Okay. So how we are going to do is, so before that, you will have lots of simple simple functions here. So if you want, you can learn this. Okay. So for example, here I will explain this just like that because it's for our understanding only. Insurance underscore dataset dot head is head when you have the head function. Insurance dot underscore dataset is nothing but your insurance variable. Okay. So now it is stored in this insurance underscore dataset. Dot head is nothing but first 5 values, first 5 rows of your data frame. Okay. So what is the first 5 rows? If in the Excel sheet you can see, there is first 5 values will be, first 5 values will be shown. Okay. So I will explain this. Okay, I just copy this code and paste it over here. So just for okay, you can see the first 5 values. This starts from 0, 1, 2, 3, 4. The first 5 values of all the independent variables. This is age, sex, BMI, children, smoker, region, and charges. Okay. And the next thing is shape. What this value will do is, again, copy and open the code cell and paste it. Dot shape gives 1338. So that is the number of rows, number of data. Okay. Number of entries is 1338, and 7 is the columns. How many columns are there? 7 columns are there. 1, 2, 3, 4, 5, 6, 7. Okay, that is the shape. If you want to see the shape of your data, then you can definitely see with the help of dot shape. Okay. After that, you will have info. What is that info will do is, it gives you all the information about the data set. So what are the informations? You can see here, data 0, 1, 2, 3, 4, 5, 6. So these are the columns. Okay, age column. In the age column, how many entries are there? 1, 3, 3, 8. And non-null, is that any null? So in the Excel sheet, some of the data may be missing. Okay, it will give that. If non-null means there is no null cell in the CSV file. So all the 6 columns have no null information, and the type, it is integer, it is in the float, it is in the object. So like that, it gives the uh, data type also, and also it gives the memory. What is the memory of this? Okay, so that is dot info. Okay, and then in case if any data is missing, okay, if any data is missing, we cannot be able to create a model. Okay, the model will get confused what to do with that point. Okay, in that case, we have to use the function called isNull. What is this isNull function will do is, it will see, is there any null, is there any empty cell in the Excel file? If it is there, what it will do is, it will sum that. Okay, it will add. So now what we are doing is, we will run this code. We can see what this will happen. So in this age, there is no null. So that means it is 0. So 0 null is there. In the sex also it is 0. In the BMI also it is 0. In the children also it is 0. Okay, if there is some null, if there is one null, here you will have 1. If there is 3 null cells in the age column, you will have 3. So like that, you will have the information. Okay. And one more thing is there, that is describe. So this is very, very useful for you. What we are doing is, we are analyzing the data set. Okay, we are not entering into the algorithm part. Now what we are doing is, we are just analyzing the data set. Describe what it will give. Just listen. All the informations. Okay, what is the count? How many count in the data set? Okay, we know that it is 1338. And then mean. What is the mean value of age? Mean value of age is around 39. What is the BMI mean? And what is the children, number of children? Okay, so all those informations you will have. Standard deviation, minimum 20%, 25% of the age, 15% of the age, 75% of the age, maximum age. Okay, all those information you will have in the describe, isn't it? So listen, a small function in the Python, in the library, okay, you will have lots of analysis of the data. It's a huge data. We cannot be able to read all the data and what is happening inside. But using this simple functions, we can able to understand, is there any empty box is there, any data is not filled, and what is the maximum value, what is the minimum value, what is the standard deviation, what is the count of the rows and columns. Everything we can able to learn with the help of this function. So that's why I have given all the functions for you. You can work on it for any data set. And one more thing, now we are moving into the Seaborn. So this Seaborn is also very, very interesting library function. You can see now, I'm just, SNS is nothing but Seaborn. SNS is nothing but Seaborn dot set. Already we have imported the library Seaborn in our data set. You can see at the beginning Seaborn as SNS. Okay. So now I am using in my code as SNS. Here you can see SNS dot set. Okay. SNS dot set. I'm just zooming out. Okay. Okay. SNS dot set. That means all the SNS functions will be imported. You can use that in your plot. Okay, so SNS dot set. After that, what I am going to do is PLT dot figure. The figure size is 6,6. That means the size is 6,6. It represents the size. And then plot. Plot is histogram. Okay, and then insurance underscore data. So that is the that is our data set, insurance underscore data set, and we are going to deal with the age column. So in the age only, we are going to see the distribution of the age. And then the title I'm giving as age distribution, and I'm going to show the plot by dot show. So just run this. You will have one different graph. Okay. Here you can see that's why that is the use of Seaborn. It gives the statistical information of your data in the picture format. Okay. Here you can see what is histogram is at the age 20, around the age 20, how many people are there? Around 190 something. Okay. In the age 20, 21 or 22 or 24, from 24 to 26 like that. How many people are there? 110 people are there. Okay, like that you can see the distribution of age using the ist plot. Okay, around 60, how many members are there? Around 90, around 80. So above 65, around 80 candidates are there in the data set. So you can visualize through the graph. So with that, we can able to understand the image. If you want to save this image, you can save it, no problem. Okay, so that is one of the advantage of using the SNS. Okay, now we have the gender. We can use the same thing for the gender distribution. Okay, how many male or female? If you want to know how many male and how many females on your data set, just use this code. Okay, SNS dot count plot. Ist plot means give the distribution of the age. Count plot means give the number of count. So in the data, what is the data? Insurance underscore data set is the data. Okay, just run it. You can have the distribution of how many male and female. Okay. Okay. How many female are there? Around 600, and the male is also around close to 700. So that's all about this one. If you want to save this graph, you can able to save it. So like that, you will have lots of functions I'm giving. You just work on the code. Okay, it's for you to work. And here, this is another interesting one. BMI distribution. Not only will have the histogram plot, you can have the distribution of the graph. Okay, if I'm running over it, okay, you can have the distribution. This is called kernel density estimation. So you'll have one graph. So around 30 is the peak. Maximum number of BMI distribution is around 30 to 35. BMI means body mass index. Okay, like that. Okay. So we can have all the children. How many children are there? We can able to see the children's. Okay, and value. How many counts? If you want means you can have the count. Dot value means count. Okay. So just work on this. Okay, when you have time, work on all these codes, functions. You can use whenever you need to analyze the data set. So this is the just how to analyze the data. So far we are discussing how to analyze the data. The important part is data pre-processing. Okay, the first step in the machine learning model is importing the library and importing the data set. And then you want to analyze the data set, you will have lots of function you can able to analyze it. Further, the important step is data pre-processing. So that is the important one. What is this data pre-processing? I already told that the machine learning algorithm will learn only numbers. It will not learn the characters. Okay. So for that, what we need to do is we need to convert the we have to convert the characters into numbers. How we are going to do is with the process called encoding. One of the simple method of encoding is this one. There is lots of encoding method. We will learn one by one when it is needed. Okay. But at the end of the session, I will cover all the encoding process. This is one method. So this method is insurance.set. So this is the data set. Okay. And then dot replace. We are going to replace in the column sex. What are the characters in the sex column is male and female. So these two are there. So for male, I am taking as 0. For female, I am taking as 1. In place true means I am directly changing the male as 0 and female as 1 in the data sets itself. I'm directly replacing. Okay, in the place of male, I'm giving as 0. In the male or female, I'm giving as 1. So that's what in place equal to. And in the smoker section, it has only two options. One is yes and another one is no. For yes, I'm giving as 0. For no, I am giving as 1. Okay. In the column of encoding region, you will have 4 regions: southeast, southwest, northeast, northwest. So for southwest, I'm giving as 0. For northwest, I'm giving as 1. For northeast, I'm giving as 2. For northwest, I'm giving as 2. Okay. So this is the way I am directly converting the categorical column into zeros and ones. Here in the region, I am converting as 0, 1, 2, and 3. I'm just running this code. What this code will do is, it will replace all that letters, all the characters are into zeros and ones, as I mentioned here. Are able to understand this? Only after this only, we have to use this data set for the algorithm to learn. Okay. So that is the third step. The first step is importing the library. The second step is importing the data set. And the third step is encoding process, okay, or data pre-processing. After this, what I'm going to do is I'm going to separate the dependent variable as well as independent variable. So that is the splitting the features and the target. Yesterday, one sir has asked me, what is features? Isn't it? The feature is nothing but the parameters in the data set. So it may be an independent variable. So these are the independent variables. So we call that as features also. Okay. Multiple times I copied that. So if you do that mistake, just delete it, no problem. Okay. So if you click that, you will have the delete option. Just if you want to put it down, click the down arrow. Okay. So now what I'm going to do is I'm going to separate the independent variable as well as dependent variable. In this case, the independent variable is age, age, BMIs, and then smoker, region, and sex. So these are the independent variables. And the last column, charges, is the dependent variable. So what I'm going to do is I'm going to take all the independent variables and store it in the X. And I'm going to take the last, that is the independent variable, dependent variable, and I'm storing to store in the Y. Just run it. Okay. How I'm going to do is insurance underscore data set dot drop. Drop means I'm going to drop the columns charges. The column name is charges. So that is labeled data or comes under supervised learning. Okay. Columns charges. I'm going to drop that. Axis 1 represents the column. The entire column I'm going to drop. Okay. The remaining thing in the data set has been stored in the X. And in the Y, what I'm going to do is insurance underscore data set and the charges. I'm going to store the charges. Just run it. Now we can see what is in the print X, or you can have X also, no problem. Okay, capital X. Okay, just put X. If you put X, then that means automatically taken as X. Here you can see all the age, sex has been converted to 0 and 1 now. BMI, children is already the number, smoke 0 and 1, region It's converted to 0, 1, 3, 2, etc. All the values. The entire values. You can see all the values. 1333 rows into 6 columns. Where is the charges? The charges has been dropped from the data set. Your X contains all the remaining variables or features. We call that as independent variable. Linear regression. It's a multiple linear because you have multiple independent variable. If you want only age, I don't want any other things. I don't want this BMI children smoker region. I want to concentrate only on age. Based on that age, I want to create one model. Then that means it comes under simple because we are using only one independent variable. Here you have multiple columns. Okay. So that is the area. And then for y, if you want to see what is y, just click the code and type y. It's a small y. Run it. Sorry, capital Y. Here you will have the options here. So you just click it, no problem. Here it is a charges column. How many charges column? You have again 138 columns. Now we have separated the independent variable and dependent variable. Now we are going to apply that into the model. Once, and then the model will learn all this data. So for this value, this is the charges. For this value, this is the charge. Like that it will learn. Once it is learned, we will use that knowledge for identifying the any values, any new values you can able to identify. Okay. Now we'll move to the next part. Okay. Now this is very important. We will use the split options, splitting the data into training data and testing data in almost all the machine learning algorithms. Why? What is the reason? Okay. I will explain why we need to convert the data into training data and to testing data. Okay. The number of data in the data set is 1338. So that is in our data set. And I'm going to split that into training data and testing data. For that, what is the code is? So this is the function for that. From sklearn model selection import training test split. So you have to know about this sklearn now. What is this sklearn now? Okay. In the Google, just type sklearn. You will have one library function. Okay. You can see scikit-learn machine learning in Python. Okay. All the machine learning algorithms are there in this scikit-learn. Okay. If you go into it deeper, you will have all the regressions, clustering, classification, pre-processing, data pre-processing, all those are there in the scikit-learn. From here only they are taking all the codes. Okay. I will explain how to take the linear regression code from this. sklearn linear regression. This is the algorithm that we are going to use. Okay. So you will have sklearn dot linear underscore model linear regression. Okay. And what we are interested in, we are interested in the train split. Yeah. Train test split. Just sklearn train test split, and you have sklearn dot model selection train test split. Okay. Here you have the examples and everything you have. If you are interested, you just go through it. Okay. Different types of things are there. Okay. Here you can see from the example, import numpy as np. I told what is that. From sklearn model selection, import train test split. So this is the line I am taking. Okay. From the library sklearn.model, import train test split function. Okay. So I'm just using that command here. You can see now in my Google Colab, I'm using from sklearn.model selection input train test split. So whatever the algorithm, whatever the function you want to use in your code, just type sklearn, the function, you will have the example and the some example codes are there and different options are available. If you want to just go through it, and if you want, you can use it. Okay, so that's the way of learning. And once I use that line, after that, what I have to do is I have to split the thing. So that is also available here. Okay, you can see the code here. X train, X test, Y train, Y test equal to train test split. X comma Y test size is 0.33, random state is 42. The same thing will be there. X train, X test, Y train, Y test equal to train test split, X comma Y test size. I am here giving as 0.2. There it is 0.33 in that example. So what that means is 20% of the data I am taking as test size. There they are taking 0.6. That means around 33% they are taking as test set. And random state is 20. Random state is you can give any number. Okay, so what we have to do is we have to give the same number. So I am giving 2 means we also give the 2. That means the same number, the same data, 20% of the data has been taken as test and the remaining has taken as training. So for the study purpose and for you and me to get the same value, we have to use the same random state. If I use say another random state, some other value will be taken as test set and some other value will be taken as train set. So and then again the value will not match. So for study purpose, we can use the same random state. So I'm just giving run. So that means your data has been split. 20% is taken as test, that is in the X test, and 20%, 80% has been in the X train. Okay, and the output is nothing but the dependent variable. Am I right? So dependent variable 20% has been taken as Y test, and 80% has been in the charges. That means charges column in the train. So why we have to do that? So that is the question. Why we have to do that? The reason is training is learning. Once you have learned, we have to test it whether it is working well or not. Am I right or not? So it is learned. My algorithm is learning all the data. Once it is learned, I have to test it so that I have to understand whether it is working perfectly or not. For testing, I have to give the values. I have to give more values. If I give random value, I don't know the answer. What is the correct answer? So from the data set itself, if I take the test as well as Y, okay, output is also there. The charge is there. The output is also there, and input is also there. Okay, so if I give the values X test into it, and it will predict some value, and then I can able to compare the Y test, the actual value as well as the predicted value. Are able to understand? Okay, otherwise I uh, don't have the actual value to check whether it is working well or not after training. Okay, we will see that in the coming part of the course. So that's why we are going to use that's why we are using splitting the data into training set and testing data. Okay. After that, we were going to see the shape of that. Shape means how much data in the training and how much data in the testing. So I'm just here you can see in the X, that means the actual shape is 1338, 6 column, but in the X train dot shape you have 1070. In the X test you have 268. So 268 data I'm going to use for testing, and I know the actual value also, because I am taking from the data sets itself. So, and then I will compare these two and to find out whether my model is working correct or. So the next step is creating the model or model training. Okay, so that now only we are entering into the linear regression. So we have studied a lot in the introduction part. What is linear regression? There is independent variable, dependent variable, and the graph, mean square error, gradient descent. So all those things we have studied. But while implementing, we no need how it is happening. Only thing is we need the basic concepts. So what is linear regression and how it is working. Remaining thing, how to use the code to create the linear regression. So it is a library one. It is also from the sklearn, from sklearn.linear model, where this line I am taking from the sklearn model website. Okay. And then regression. Regression is the variable that I'm giving, and I'm giving linear regression function. So once I run that, my model has been created. So you can have now the linear regression is there in the variable regressor. Okay. Now the next step is we need to train. We need to train. So for that, this code has been used. Regressor. So regressor is the variable of the linear regression. Dot fit. Fit is the training. Dot fit is nothing but a function for training. And from what is the value that you are going to train is x train and y train. So x is the independent variables and y is the dependent variable. I'm going to train with that values. So this is the values 1170. Now the model has been created just like that with one click. Okay. Once we created the model, we have to evaluate the model. We have to test the model whether it is working well or not before giving it to the customers, isn't it? So how I'm going to test is we have certain parameters for that. So that is called metrics. Okay, just giving the code from sklearn import metrics. Test data prediction. So this is the predicted value that line. Okay, test data prediction that is equal to regressor. Regressor is the model that we have created, and predict is the function, and the x test is the values that I splitted. So I splitted 20% of the data for testing. Okay, so I'm taking that value here. Okay, and I'm going to use the function predict. Okay, what the predict will do? It will predict the y value for this text. Okay, for this test value, it is going to predict the y value, and that y value is storing in the test data underscore prediction. Are you able to understand this one? Okay, so that's the purpose of splitting the training data into training and splitting the data. Okay, I'm just running it. Now it has predicted the values. Okay, and the next step is we are going to see whether the predicted value is correct or not. Okay, then only we can able to say the model is working correct. Okay, how I'm going to do is, here you can see one is R2 matrix. In the sklearn itself, you have R2 matrix is there. So matrix dot R2. Okay, R square value. So nothing but R square. Mean square value. We have seen mean square in the linear regression. No, that's it. Okay. Now R test is the variable matrix dot R2 score. Okay, y test. What is y test? Y test is the data that we have splitted. For the x test, there is some y test. For the x train, you have the y train. For training, we have to give both train, x train and y train. For test, we have to give only the x train. And the model is predicting the charges. That's the y value. the model itself predicting, because it's already created. The model is already created. Now, the predicted value is being stored in the test data prediction. And y test, what is this y test? Y test is the actual value that is available in the data set, from the data set. Okay, here you can see that's value. When you move the cursor, it is showing that. Okay, so now it will compare these two values, the existed as well as the predictor value. It will compare these two and it gives the percentage. What is the percentage? 74. Around 74% of the values, the y test, the model has been predicted correctly. Okay, the accuracy here is 74%. So that means 70%, 74% of the y test is matching with the prediction. So the accuracy of the model is how much? 74%. If you want to increase the accuracy of the model, what you have to do is you have to train more. Okay, and then it is also depending on the data also. There should be a linear relationship between the input data, independent variable and the dependent variable. If that is also not matching, means definitely there will be reduction in the accuracy. So that are the things we have to consider. But anyway, 74% is not a bad prediction. It is an average prediction. Okay, so with that accuracy, we can say the model is working 75% accurately, working with 75% accuracy. Now we have created a model and we tested the model with the data also, and we have calculated the accuracy also. So that's the end of the creating the machine learning model. Now we are using that model for the customer. Any value, he don't know the charges. Output he doesn't know. But only thing is he know what is the age, everything we can able to fill. The customer has to see what is the charge he has to pay for the medical insurance. So that is the model we are going to create. For that, I am going to use this code. What is that means? First the input data. So this is the input data that is given to the customer. The customer is giving. What is the input data is giving? 31. Okay, is the age, and then is a male or female. Okay, and then mass index BMI is giving, and then is a smoker or not is giving, and then this one is the region, is giving the region. Okay, so like that is giving all the parameters. We're able to understand this. All the 6 values, 1, 2, 3, 4, 5, 6. All the 6 values is giving. After that, these values has been converted into array. Okay, what we have done in the CSV file, we have taken the CSV file and we have converted that into using the pandas. We have separated that into rows and columns, and we are giving that in the. So for us to give this value into the predictor, we have to convert this into array. So I'm changing that to array format, and I'm reshaping the array. Why I have to reshape the array? We have to give it in the 2-dimensional one. In the model, we are giving in the 2-dimensional one. So here also we are going to giving in the 2-dimensional one. That's why I'm reshaping as 1, -1. Okay. And then finally, prediction regression. Regression is the model that we have created, and we are going to predict. And what is the value that you are going to give us? Input data reshaped. So that is the value from the customer. Unknown customer is giving, okay, to the model, and the model is going to predict the cost of the insurance. So how it is going to do that? It's based on this value. It is predicting as $3,760, okay, or rupees. Okay, it gives the customers this much value you have to pay for the insurance. So even though it is 74%, we can use this. Okay, you can increase the accuracy with some changes in the data sets, or with the more data training we can able to do that. But anyway, our aim here is to create a model, and we have to use that model for a customer. Any customer may come to the insurance company, and they have to give these values, and they will see what is the amount they have to pay for the insurance. So this is AI, okay, based on linear regression.